Hello boys, welcome to page 3 of the tech-free SAC solutions. I've got a straight line here and a parabola. Just checking how much space I've got. I've got a bit of space, but it looks like a long question, so I'm going to make sure I work on the left-hand side in case I need to divide it in half. I've got to find out how many times that line and parabola intersect, so I probably need to solve simultaneously, and I really only have to show how many by using the discriminant. But first of all, I'm going to solve simultaneously. I'm going to let the parabola 2x squared minus 4x and 5 equal equation 1, and the straight line 2x plus 1 be equation 2, and then I'm going to solve by substitution. I'm writing it all out for you for y, and so I'm going to go 2x squared minus 4x plus 5 equals minus 2x plus 1. Bringing to the same side, 2x squared, take 4x plus 2x and 5, take 1 equals 0. 2x squared, take 2x and 4 equals 0. I am going to just go down. Have I got another line? I do. Got another couple of lines. Still going to divide this in half here. Might be handy. To solve that, I'm only asked to use the discriminant. So I'll do my work up here. I'll let A equal 2, B equal minus 2, C equal 4, and I'll sub them into the discriminant, which is B squared minus 4AC, which is minus 2 squared minus 4 times 2 times 4, which is 4 take. Well, that's 2 4s are 8, 4s are 32, which is, well, it's negative. It doesn't actually matter what negative number it is. It's negative 28. Therefore, no solutions. Of course, if it was equal to 0, there'd be 1, and if it was greater than 0, there'd be 2. There are no solutions. No times when that straight line meets that quadratic. It was a good thing that I worked on the left and divided my thing in half. I had lots of room to work. You're going to get 3 marks. You're going to get 1 for the answer no solutions. You're going to get 1 for solving simultaneously, somewhere in here, probably there, and a bit of grouping and stuff, and you're going to get 1 for correctly substituting into the discriminant. Down to similar question. Find the coordinates of the point of intersection of these graphs. So this is a very similar question, and we're going to do something very similar. We're going to let y equal minus x squared and 3x minus 10 be equation 1, and y equals minus 2x minus 6 be equation 2. You could have perhaps just written that on your paper. And now we're going to solve by, letting 1 equal 2. And so we will get, I'll just do it here, negative x squared plus 3x minus 10 equals negative 2x minus 6. Wouldn't mind making the x squared positive, or we'll do it later. So negative x squared plus 3x plus 2x, if I add that 2x over, minus 10 plus 6 equals 0. Negative x squared plus 5x minus 10 plus 6 is minus 4 equals 0. I'm going to take out the negative. X squared minus 5x plus 4 equals 0, and I've got a feeling that'll factorise because 4 times 1 is 4 and 4 plus 1 is 5, so I might do that. I've worked down the left, I've divided in half. I could, just to make it clear, do that. Then I've got negative. It's going to be x minus 4 and x minus 1, of course, because that multiplies to plus 4, but it adds to minus 5. null factor law, therefore x minus 4 equals 0, or x minus 1 equals 0, therefore x equals 4, or x equals 1. Better look back to see what the question was asking me. Coordinates of the points of intersection, thought so. Got to sub them in. Clearly it's easier to sub them into 2. We get y equals minus 8 minus 6, and on this one we get y equals minus 2 minus 6. Y equals minus 14, y equals minus 8. You would then put 4 minus 14 and 1 minus 8 as your answers. Had lots of lines, didn't check, should have. 4 marks. 4 marks is probably not enough for that question. You could easily have got more. I reckon there would be 1 for this working over here where you equated the two equations to solve. I reckon there'd be 1 for where you factorized, and then I'd probably just give 1 for each of the answers for the 4 marks. So the major working there was equating the equations, was factorizing to solve, and then obviously from that factorized form you can see the 4 and the 1. You've got to get the y's, so really it's sort of 1 for getting those two y's, and then expressing as coordinate pairs. I think that's the end of page 3, so I'll say